Hello everyone, this is Lucas from Zolvio. Today I want to show you how you can generate your Apollo data sources. Part of working on your GraphQL aggregation layer is to have your resolvers connect to your microservices. And to do that, the typical workflow would be to check what endpoints are available to you on a given microservice, then check what arguments you can send to that endpoint and what form of the arguments the endpoint takes. And then you have to verify what shape of the data you can expect to get in return from that particular endpoint. And setting it all up is boring and error prone. We wanted to have a tool that would help you eliminate this problematic part of creating your aggregation layer. So let's jump to the code, and I will show you how you can use Chimp to generate the data sources. To start with, we have a simple GraphQL. We have a simple microservice, Java Spring microservice that has an endpoint that returns the all the lists available, and then we have a separate endpoint that you can use for adding another list. When we query, when we call this endpoint again, you can see that the list was added. So this is as simple as it really gets. So let's create an application now that will use these two endpoints. So I use Chimp to create the scaffold for the GraphQL server. You don't have to use it to benefit from the data sources generator, but it's definitely handy. So let's wait a second here. And I guess we can jump to the IDE now. So the first thing we need to install is Apollo data source REST. This is not included in the scaffold by default, because you might have a GraphQL server that actually has all the business logic inside without calling external microservices. So that's something you have to install yourself. And the second part is the Chimp data sources generator. Again, we don't assume that you are actually going to use data sources or that you are going to connect to the external REST endpoint. So that's not provided by default. Having these tools in place, you can now use the Chimp data sources generator with a create command. Then you specify to which folder you want the API to be generated, in which folder you want it to be generated. And then the last argument is either a path to a file that has the schema for your microservice in the OpenAPI format, or URL to that file. So in our case, we'll go to the microservice directly. And this is a very typical URL for the OpenAPI in Java Spring. So let's call that. So you can see the API here got generated. Let's actually add all the stuff as a first commit, so we have a clean state to work from. The first thing we need to do after generating the API is to add it to a function that will provide the data sources. So this is a typical Apollo pattern. We're just gonna say new controllers, and we'll import this one. We need to pass here URL to the microservice that will be used for this controller. In a real life situation, you'll probably want to have some kind of environment variable that will specify the URL to either your local environment, your staging environment, or your production environment. And also, you'll throughout the video, you'll see this kind of a silly error here from ESLint. Sorry, I forgot to fix this problem. There's something, new problem with ESLint. Doesn't really matter for the purpose of this video. So we set up the data sources now. You can see that they are just added the standard way to your Apollo server. So nothing surprising here. With the data sources in place, now we can create a GraphQL schema and start implementing our query and then our mutation. So by default, there is an example in the chimp scaffolding. You can just remove that folder altogether and create a new schema GraphQL file. We want to have a type list with a name. And then we want to have a query that will get all the lists. We extend the query because our generator already have some GraphQL schemas that define the query. So for IDs to understand that we are not redefining, we are just adding more queries, we use the extend keyword, which might or might not be relevant to your setup. So with this schema in place, we just run GraphQL generate all. And that will result in a few new files here. One is the specification for our query resolver. And the second one is the actual resolver. I'm going to quickly configure Wallaby here so we can run the tests. You can also just use jest in your console. So as you can see, the test is obviously failing because we haven't really created a test nor implemented the resolver. So in the spirit of TDD, let's start with the test. So what happens here is that we are creating a mock of the GraphQL context, and that context actually includes the data sources. So this is this context here is what you will have as the third argument in your resolver. So we want on the context, we want to get to data sources, list API, and then we have the actual controller, and then we have the actual method. So we want to say that when someone calls this method, we want to resolve with an array of lists. So let's create that. You can see that the IDE, everything is typed, so IDE is helping me here to fill the required fields. Like you can verify that if you mistype something, TypeScript will be complaining, which is great because that gives you a high level of probability that everything will work properly. Let's create a variable with this array. Make this const. And then we want to expect that the result of calling the resolver function will be that list, that array of lists. So now the implementation of the resolver is actually super simple in our case because we can basically just copy and paste this. And as you can see, the test is passing. Everything is connected. And again, this is all typed. So if you just return an object of some kind, then you'll get errors saying that this object that you are returning here doesn't match what the GraphQL expects to get from this particular resolver, which is very handy. and you didn't have to set it up at all. It's all automatically done for you. And now the next thing would be to create a mutation. So the type list here is complaining because we've generated a combined schema, which redefines some fields. You can just mark that as plain text, and you can see that the error goes away. So we want to create a mutation here that will pass the name to the microservice, and then that it will actually return the new list as the result of the mutation. So again, we generate some code. And now we can open the specification one side. Oops, not for the query, for the mutation. Specification on one side and the actual mutation on the other side. And again, we want from the context, data sources, list API controller, we find a method that interests us. In our case, we want to create a list. That create list looks like it takes an text argument. You can make a variable out of that. So this is new list name. And then we want to resolve an object with the new list. So the name is the new list name. Now we need to set up the variables for the mutation. And then we expect the resolver to actually return the new list. So to do that, then let's extract this part to a variable. And now, again, we can copy and paste it. It will not work yet because here we need to actually use the arguments passed from the GraphQL. And once I did that, you can see that the tests are passing. So now the remaining thing is to just start our GraphQL server. We need to have a different port because we have some services running in the background. So let's just call it on 1235. And let's see. So the first thing we can do is just run the query. So we have a query get all list, and from that we want to take name. Let's preify that. You can see that we get all the lists back, and then the next thing we want to check is mutation. We have add list mutation that takes the name as an argument. Hello world again. Oops. Why? And then we just want to get name from it. Let's preify. Let's call it. You get the hello world again back. And now when we call the query again, you can see that the list is added. So this is clearly a very simple example. But the point is that the more complex cases actually should be as straightforward. And the actual complexity at this point should come from your business logic and the way you want to aggregate data coming from your different microservices. And not from setting things up and gluing things together and figuring out how to call your microservices and what data shapes to expect coming from them. So we've basically removed the boring, mundane part, and now the remaining is the stuff that should be valuable to your business. So yeah, thanks for watching. Please let me know if you have any questions. I will add the links to this code and to some more complex example.